My name is Pascal Schlatter from Group 8 at the University of Nottingham, and a project that we've been working on is called Changing Energy, which was done in conjunction with Changing Energy and IBM. The goals of these projects were to analyze social media for do some sentiment analysis on specific topics, and then on top of that also try and predict energy prices amongst various factors through Watson machine learning. The first demonstration we have here through our final submitted demonstration website, which we use as a front end for the APIs we developed through Node-RED. We have some Twitter sentiment analysis for 3 key energy companies within the UK. What this basically is doing here is it's a Node-RED backend basically, constantly looking out for some keywords that specifically have to do with British Gas, E.ON, or EDF Energy. And then it passes these through a Watson sentiment analysis where it makes an accurate guess based off of the tone that's going on in the tweet that's been sent out and sort of the words that were being used, if this is something that's positively speaking about the topic or neutrally or negatively. And then it does this on a 24/7 basis and sort of keeps track of everything that it's seen so far. And then here are some live predictions, or live, not predictions, more analysis of multiple tweets. So we have 212 tweets about EDF Energy, and then here you can see the breakdown of how people are currently talking about this. On top of this, we have the price prediction, the actual prediction based off of a large amount of data. So we were presented with a lot of data, and our task was to try and figure out a way to analyze this data into a machine learning model where we could just have the ability to make some predictions. And the way that we've done this is that we took the data, we created a machine learning model that takes a specific amount of inputs with everything to do with daily supply of oil coming into the country minute by minute versus sort of the history of the weather this past month. And then it takes all this into account and makes predictions every 2 minutes. So here you can see sort of a timeline of when these predictions are being made. It being 2 minutes, there's not big fluctuations, despite that there are really big changes within the amount of oil or the amount of product actually coming into the UK. But you could see over time that these do change. Sort of apart from this demonstration, we have these two kind of demo things that we have out front and center for people to see and actually engage with. On top of this, we have some information about us being part of the team, what the project was about, kind of a breakdown of everything that we were trying to build and what we used to do. And then on top of this, we also have a blog where you could go on and visit and then track our progress since the start of this project. To draw on the actual development that was done to create these endpoints and to create these functionalities that can be everly expanded on, obviously, we decided that we wanted to build backends and APIs that would really simply display the data and make it really easy to interact with these relatively complex Watson services. So the 3 key APIs that we mainly deal with here are the prediction endpoint. This one, all of these are powered with Node-RED. This one specifically takes into account various factors and formats them all in the back end while pulling the most live and the most recent accurate data. And then it makes a prediction and it just returns a simple oil price and a simple history of how the price has been changing, so you could format it into a graph over time. Another endpoint that we use then is the Twitter sentiment. This is always running in the background and it's keeping track and updating its own database for everything and all sentiment that's going on. And a user can basically just simply reload the page and get the most accurate information. And if you do this periodically, the information will update in a live way. And the same goes for the make prediction. The weather data is slightly different. This is something that we feed into our machine learning model, but obviously we need an API that can take sources from various websites and kind of collect them into a really general and a really understandable way. And this is how we do that, and this is the actual endpoint that we use in our machine learning and our prediction model. along with various other ones. Each of these APIs lives in our Node-RED flows, so each Node-RED flow has an entire structure where the API is deployed, and all the logic and all the requests are just flowing through there, and then it will eventually give you a response based on the machine learning decisions that it made. This machine learning flow specifically did not originally exist in Node-RED. This was something that we had to come up with as a team to understand ourselves and to make use of. To view any of these flows, or to view any of our source code, we have our GitHub, where we have a production branch where you can actually see the full timeline of how everything works and the nitty-gritty down low source code for how each of our functions work as well. We'd implemented a brand new Git strategy, which we had to do as Node-RED did not have its own inherit and built-in Git system. So this was a function that we had to come up with ourselves as well. And if you ever have any questions about how the Git is organized or how these things work and how to use it together with Node-RED, there are various descriptions that were written here that can kind of walk you through the process of using Node-RED in Git and how to go through our own Git and how the organization structure works. There's all kinds of interesting information here as well, along with any links that you need for our user manual or our software manual as well, where there's a further breakdown of why we chose to do what we did and really how to make use of all of these things. And then a user manual would be more for the end user. I hope you enjoyed this quick presentation of our project and what we've produced at the end of the group project so far. I'm looking forward to building a bit further on this and coming up with some good demonstrations for our presentation day, and I hope this was helpful for you. Thank you.